Now we talk about another elasticity that is very important, and that is the cross elasticity of demand. The cross elasticity of demand measures how demand for one good changes if the price of another good rises by 1% in this case. So mathematically it means that we calculate the expression epsilon qxpy. So what happens to the quantity of good x if the price of good y changes, and that is then the percentage change in the quantity of good x divided by the percentage change in the price of good y in the discrete case, and in the continuous case again we have the derivative instead of the discrete change denoted by delta. The most important aspect determining the cross elasticity of demand is whether the two goods under consideration are substitutes or complements. So of course, if the two are substitutes, then if the price of good y increases, then the quantity of good x would increase because people substitute this good for the other good that has become more expensive. By contrast, if the two goods are complements, then if the price of good y increases, then demand for good x would decrease because the other good gets more expensive. But since the two goods are complements, they are typically consumed together, and therefore the demand for good x would decrease in this case. So let's look at some examples. The first one here is that you have two different brands of shoes, X versus Y. So these are clearly substitutes. The cross elasticity in this case would be positive, which means that if the price of good Y increases, so if the brand Y becomes more expensive, then people would substitute good X or brand X for brand Y, so they would consume more of brand X. Therefore, the cross elasticity would be positive. So a percentage change in the price of Y induces a positive percentage change in the demand for good X. By contrast, if you have two complements, say hiking shoes and a backpack, then the cross elasticity would be negative. So if hiking shoes become very expensive, then perhaps people would not want to go hiking that much anymore, and therefore they also need fewer backpacks. So therefore the cross elasticity would be negative. If the price of hiking shoes increases, the demand for backpacks would decrease. And finally, of course, you could have a lot of goods that are completely unrelated, say bottles of wine and car tires. In this case, you would expect the cross elasticity to be close to zero. So if the price for car tires increases, you would not see any change in the demand for wine. Also, the cross elasticity of demand can be written differently to what we've seen before. So we can multiply out again here and get the price level of good y divided by the quantity of good x, multiplied by the change in the quantity divided by the change in the price. Or in the continuous case, you get the same expression here, the price over the quantity, and then the derivative of the quantity with respect to the price level. So that would be the elasticity. And in the continuous case, we can again take instead the derivative of the logarithm of the quantity with respect to the logarithm of the price, and that also leads to the cross elasticity in this case, because that's the price of good y. And again, as with the previous elasticities, this is often very important if you analyze the elasticities empirically, because then you often have the data in logarithms, and when you regress the quantity of good x, the logarithm of the quantity of good x against the logarithm of the price of good y and perhaps control variables, then the coefficient of the logarithm of the price of good y is directly the cross elasticity in this case. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.